Okay, let's unpack this. Imagine if Earth isn't just, a quiet blue marble drifting silently through the cosmos, but actually a giant, unintentional cosmic billboard constantly broadcasting our existence out there. For this deep dive, we're looking at some fascinating new research. It suggests our everyday technology, specifically radar signals, might be acting as a kind of "we're here, come find us" beacon for, well, intelligent alien life.
It's really quite something. What's fascinating here is how this research explores what they're calling hidden electromagnetic leakage from Earth.
Hidden leakage,
Oh,
like accidental.
exactly. Think of it maybe like sound escaping a room when a door isn't perfectly sealed. Our powerful radar systems, they aren't designed to broadcast deep into space.
Right.
But a tiny bit of their energy, it inevitably escapes and travels way beyond where it's meant to go.
Ah,
So
okay.
yeah, this deep dive will distill the key findings about these signals. It reveals not just the potential for aliens to detect us, but also, how far out we might detect similar signals from other worlds.
Mm.
It really has implications for that big question, are we alone? And also for more practical things like how we manage our own technology.
So it's not about sending deliberate messages like a receivo or something. It's
Yeah.
our everyday tech just humming away.
Precisely, it's the mundane stuff.
But how? How could something like air traffic control possibly broadcast across light years? What's the mechanism?
Well, it's that hidden electromagnetic leakage again. The research points to both military and civilian radar signals as the main sources.
Okay.
These powerful signals, used for tracking flights, weather monitoring, all that, they're just not perfectly contained. And the new findings suggest this unintentional spillover, it could be visible to aliens up to maybe 200 light years away.
200 years.
Yeah.
It's quite a reach.
It is, but there's a condition, provided they have, state-of-the-art radio telescopes comparable to ours. Think something like the Green Bank telescope.
Right, right. And this is fascinating because it works both ways, doesn't it? If our signals are detectable that far out,
Then yeah, it stands to reason. Similar signals from their home worlds could potentially be detected by us.
it creates a sort of cosmic two-way street, even if it's completely accidental.
Absolutely. And Ramiro Caicedo from the University of Manchester, one of the researchers, he puts it quite well. He says that radar signals produced unintentionally by any planet with advanced technology and complex aviation systems could act as a universal sign of intelligent life.
A universal sign.
Wow.
Yeah. It really supports that scientific quest for ET, kind of guides our search maybe, and it also impacts how we view managing our own tech here on Earth.
Okay, here's where it gets really interesting for me, though. The research didn't just theorize this, right? They actually simulated signals from specific places.
They did. Major worldwide aviation hubs. We're talking places like O'Hare in Chicago, JFK in New York, Heathrow over in London.
Wow, so everyday airport operations giving off clues to our existence across the galaxy? That's kind of wild.
It is. The team figured out the detectability by simulating how these radar signals would spread out from Earth as they traveled through space.
Okay.
And then they considered how detectable these signals would be from relatively nearby stars, using our own best instruments as the benchmark.
Makes sense.
So, for instance, they looked at Barnard's star. That's the fourth nearest star, about 5.96 light years away. And also AU Microscopia, which is around 31.7 light years out.
And what did they find?
Well, their findings revealed that the combined radio signal, just from major airport radar systems, it's strong enough to be picked up as far as 200 light years away.
By telescopes like Green Bank?
Yeah, by telescopes comparable to our Green Bank telescope in West Virginia. One of our largest steerable radio telescopes designed for extreme sensitivity.
And bringing it even closer to home. You mentioned Proxima Centauri b before. That's the closest potentially habitable exoplanet, right? Only 4 light years away.
That's right. Very close, cosmically speaking.
So if there is intelligent life there, and they have radio telescopes, they could detect our leaked signals. That's just mind-blowing.
It truly is. The potential for detection at those closer distances is definitely there. But, I sense a but.
Well, just a reality check on travel. Even if Proxima Centauri b had, say, highly advanced spacecraft traversing those 4 light years, it would still take many thousands of years with known physics.
Ah, okay. So detection, maybe? A visit?
Yeah,
Not so much. Not anytime soon, anyway.
exactly. While detection is possible, an immediate visit isn't really on the cards.
Which is maybe a bit of a relief for some people. But, okay, speaking of what they might hear, you mentioned different kinds of radar. Are these accidental broadcasts all the same, or are there different signatures?
That's a really good question. Civilian radar, like the airport stuff we've been talking about, tends to produce broader signals, more widespread, kind of like a general hum, maybe.
Okay, a general hum. And what about military radar then? I'd guess those are different.
They are quite different, yes. Detecting military radar signals is a different proposition. These signals are typically much more focused, more directed. Think of them like lighthouse-like beams that sweep across space. Because they're designed for precision targeting and tracking, their leakage profile is distinct, sharper.
It was particularly compelling. The research says these military signals would look clearly artificial to anyone watching from out there with powerful radio telescopes. So not just random noise.
Precisely. A distinct engineered signature.
Right.
Romero Quesada also points out that these military signals, they can appear up to 100 times stronger from certain points in space, depending on where an observer is located.
100 times stronger. Wow. So they could be a really strong beacon from certain angles.
A very clear artificial blip that would really stand out against the cosmic background.
Okay, so let's pivot a bit. What does all this mean for us here on Earth, both, in our search for alien life and maybe for our own technology?
Well, first off, it gives incredibly valuable insights for astronomers scanning the skies for SETI signals for intelligent life.
Yeah.
It's effectively giving them a much clearer picture of what kind of signals to look for, the frequencies, maybe even the patterns to anticipate if an advanced civilization is doing something similar to us, like running airports or military radar.
So it helps narrow the search, like knowing what station to tune into.
Exactly. Rather than just scanning randomly across the dial, you have a better idea of what an artificial signal leakage might actually look like.
And you mentioned it's not just about aliens. It could have practical uses for us, too.
Definitely. This research can significantly help us perfect our own terrestrial radar
Oh,
systems.
they blow away.
By understanding precisely how our signals travel and leak into space, we gain insights into signal propagation. That knowledge can be used to protect our, frankly, very crowded radio spectrum for vital communications.
Preventing interference and things like that.
Yes, and it can also inform the design of future radar systems, maybe making them more efficient or, if we ever wanted to, intentionally designing them for interstellar communication rather than just accidental leakage.
So the methods they developed here for modeling and detecting these really faint signals, they have wider applications than just hunting for ET.
Absolutely. Think about the bigger picture.
Okay.
This kind of modeling, understanding signal propagation in space. It can inform astronomy in general, maybe planetary defense, helping us detect incoming objects more effectively, perhaps.
Right.
And even just monitoring the impact of human technology on our immediate space environment. Things like space junk, satellite interference. It's all connected.
It's about understanding our footprint.
Our footprint,
Yeah.
yeah. Understanding that our daily activities here on Earth aren't just contained to our planet, they ripple outwards.
It really puts things in perspective. And just for context for you listening, this research we've been discussing, it was presented recently on July 8th at the Royal Astronomical Society National Astronomy Meeting, NA 2025, held at Durham University in the UK. So we've explored how our everyday activity, everything from air traffic control near Chicago to military operations, creates this powerful, completely unintentional beacon, basically advertising Earth's intelligent life across the galaxy. It's quite a thought, isn't it?
It really is. And building on that, maybe here's something for you to mull over. If our daily technological footprint is already this cosmic billboard, inadvertently giving away our location, how does that change our perspective on managing our technology's influence, not just here on our planet, but out there in the vastness of space, especially when you think about future space communications or planetary defense or just our presence? It raises a pretty fundamental question about how we as a species consciously or, unconsciously project ourselves into the universe. Something to think about.